Hi guys, so today we're doing area of regular polygons and circles. Before we get started talking about the formula, we're going to talk about a key part of the formula, which is something known as an apothem. Okay, so here we're looking at the a regular octagon here, octagon A, B, C, D, E, F, G, H. It is inscribed in circle Q, right? So note that Q here is the center of the circle, okay? As well as we can say the center of this octagon, okay? Here, QA and QH are radii from the center of the circle, and it also is the vertices of the octagon, okay? And so here you can see that it forms an isosceles triangle, okay? Then split through the middle, we draw a segment here that is QJ, okay? It's drawn from the center of the regular polygon and it's perpendicular to the side of the polygon. This is known as the apothem, okay? And so what the apothem does is it splits that side in half. It also splits that angle in half, right? There you go. Okay. And it's from there that we get the area of our regular polygon, right? So we can imagine that we broke up this octagon into smaller triangles. Okay. Then basically the area of each triangle is 1/2 base times height, or in this case 1/2 of the side length as the base, and the apothem is the height of that triangle, right? 1/2 SA. Okay. Then, since this is an octagon, we have 8 of these small triangles, and so then we can say that it's 8 of the 1/2 side apothem, okay? And then 8 times the side, well, that's the perimeter, right? 8 times the length of the side, that's the perimeter, so that's P, and so that's how we get the formula for a regular polygon. It's 1/2 perimeter times A. So with that in mind, we're going to get started with our first example. Okay. So here it says, find the area of a regular pentagon with a perimeter of 40 centimeters. Okay. So basically, what we know, then if it's 40, okay, divided by 5, okay, each side is 8. Right, so if it's perimeter of 40, okay, that means each side is 8. Okay. Each angle, right, so all the way around is 360, and then 360 divided by 5 is 72. So here what we know is that angle NPM measures to be 72 degrees. Okay. How does our apothem, which is PQ, come into play? Well, it splits it in half, so it splits this side length of 8 into 4 centimeters, and it splits this 72 degree angle, this 72 degree angle here in half, which makes this 36 degrees. Okay? And then now, to find out what this apothem is, we can use trig, right, because it's a 90 degree angle here. So this is opposite, this is adjacent, so that's tangent. So tangent of 36 is opposite the 4, right? Opposite. And then adjacent, or the apothem here, is the adjacent. You can do the math, it'd be the same as saying the apothem is 4 divided by tangent of 36. Okay, in order to keep my answer as exact as possible, I'm just going to plug in this for the apothem. So area for a regular polygon is 1/2 perimeter times apothem. So that's 1/2. The perimeter we know is 40 centimeters. Okay, and this apothem is whatever 4 divided by tangent 36 is, that amount of centimeters. Okay. Right, so I could have figured it out, but then it would have been a decimal answer, and I want it to be as exact as possible. Okay, so that's why I'm writing it in as this and then just typing it into my calculator. Okay, so half of 40 is 20. 20 times 4 is 80, and then I'm do 80 divided by tangent 36. Okay. And that gives me approximately 110. The book shows to round to the whole number, but you would have gotten something like 110.1106. And then centimeters, this is area, that's why it's square centimeters. Okay. But your book just rounded it to the nearest whole number and wrote that it was 110 square centimeters. And there you go. Right. So why don't you try CYP 1A and 1C? So not all of them, just 1A and 1C, and then once you're done, come check your answer. Okay, so for 1A, you should have gotten approximately 1,160 inches squared. And then for 1C, you should have gotten approximately 1,122 inches squared. If you got that right, you can move on to our next example. If not, here is your explanation. Okay. So for 1A, we want to find the area of a regular octagon. So I kind of drew a little octagon picture here. And I know that its perimeter is 124 inches, right? So again, perimeter is all of the sides, and since it's regular, all sides are the same. So octagon is 8 sides, so 124 divided by 8 is 15.5. So each side is 15.5. Okay? Right. And then, right, I can divide up this octagon into these different triangles. Okay. And the angle measure for this part of the triangle, since all the way around here is 360, 360 divided by 8 is 45. But when I split it with the apothem, it splits the side length in half, so that's why this part is 7.75, half of 15.5. And then this angle, which was 45, gets split into 22.5. Okay? Then to find the apothem, opposite, adjacent, that's tangent. So tangent of the angle, 22.5, equals the opposite, which is that half of the side, 7.75, over the adjacent, which in this case is my apothem. Okay. So that means apothem is 7.75 divided by tangent 22.5. Area for a regular polygon is 1/2 perimeter, which I was already told is 124 inches, times the apothem. Type that into my calculator. This is about what I get, and then the book wanted us to round to the nearest whole number, so that's 1,160. 1C here is a hexagon. This time, though, instead of giving us the perimeter or a side length, it gives us the apothem. Okay. So here's my little hexagon. Okay. My triangles. Okay. So all the way around is 360. Since it's a hexagon, 360 divided by 6 is 60 degrees. And then since the apothem splits it in half, this is now 30 degrees here. This apothem is 18, 30, 60, 90 triangle, right? That means this is the long leg, this is the short leg. Long leg is short leg times square root of 3. Okay. Divide by square root of 3, simplify that, that's 6 square root of 3. And that's only half of it, right? Because of this split here. So then double 6 square root of 3 is 12 square root of 3. Okay, so that means one whole side here is 12 square root of 3 inches. Okay. So area is 1/2 perimeter apothem. So perimeter, each side is 12 square root of 3. Since there's 6 sides that are all regular, the perimeter here is 12 square root of 3 times 6. And then the apothem we already knew was 18 inches. Multiply all of that together. The exact area is 648 times the square root of 3 inches squared, which is approximately this. And then just to keep it consistent, I also rounded it to the nearest whole number, so 1,122. Okay, the next part we're going to do is area of a circle. That should be quite familiar with to you, so I'm not going to really say much about it, but we know that the area of a circle is pi r squared. Right. So here, in example 2, a caterer has a 48-inch diameter table. Okay, so you see that here. Here's the table, diameter of 48 inches. Okay, we know that it's 34 inches tall, And since she wants the tablecloth to touch the floor, that's going to give it an extra 34 inches here. Okay. We want to find the area of the tablecloth in square yards. Okay. So this is the 34. This is so that it touches the floor. This is for the table. It's 48 inches, which means then that the radius here is 24 inches, right? Because half of the diameter, if the diameter is 48 inches, half of that is the radius. That's 24 inches squared. Okay. But then we're giving it some extra space, so we're gonna, since we want it to touch to the floor, so we're gonna add that extra 34 inches. Which gives us 58 inches total for this now bigger circle for our tablecloth. Okay. So area is pi r squared. My radius is 58 inches. I'm going to square that. So 58 squared is 3,364. And then times pi. And then inches times inches gives you square inches. So this is the exact area. And then here, it asks us to change it into yards. So that's what we're going to do. We're going to end up changing it into yards. So I'm going to sidetrack this. 3,364 pi inches squared. Okay, let's change it into yards. Okay, so we know that there is 12 inches in a foot. And we got to do it again to get rid of the inches squared. So 12 inches is a foot. Okay. And then to change it into square yards, we know that a foot, we need to cancel this, is a yard. Oh, sorry, 3 feet is a yard. And then 3 feet is a yard. Okay. Alright. So the inches squared gets canceled by this and this inches. This feet gets canceled with this feet gets canceled with this feet, leaving us with yards. So 3,364 divided by 12, divided by 12 again, divided by 3, divided by 3. Okay, and then I'm going to times my pi in this time. Times my pi in. This gives me approximately 8.1546 yards squared now. And so then the book just rounded it to 2 decimal places, so approximately 8.2 square yards. So this is the dimensional analysis that we did in pre-algebra coming back into play. Okay, so why don't you try CYP2, and then once you're done, come check your answer. Okay, for CYP2, the exact answer is 56 pi square inches, or approximately 176 square inches. If you got that right, you can move on to our last example. If not, here is your explanation. Okay. So Susanna's planning to paint the circular frame for a mirror, right? She wants to know the area of the frame, right? Because she's obviously not painting over the mirror. She's just painting this part of it. Okay? We know the diameter of this whole thing, right, is 18 inches, and the diameter of the mirror is 10 inches. Okay? So if we know the whole thing and we subtract the mirror, that will give us just the frame. Okay? So that's what we're doing. The area of the whole thing minus the area of the mirror will give us just the part that she needs to paint. Okay? So here, if the diameter of the whole thing is 18 inches, that means the radius is 9 inches. If the diameter of the mirror is 10 inches, that means the radius is 5 inches. Okay? They're both circles, so pi r squared. So pi, 9 inches squared. 9 squared is 81, so 81 pi. Then mirror, the radius is 5, so pi r squared, pi, 5 inches squared. 5 squared is 25, so minus 25. 81 pi's minus 25 pi's, there's 56 pi's. Okay. And then 56 pi is approximately 176. And there you go. So the last part here. Okay. The last example here is to find the area of the shaded region. We're assuming here from the directions that the triangle is equilateral. Okay? So basically, in order to find the area of the shaded region, we need to do the area of the circle minus the area of the triangle. Okay? Area of a circle is easy because we already know the radius. Okay? But finding the area of the triangle is going to be a little bit harder. Okay, so I'm going to just zoom into the triangle here. Okay? So since it's equilateral, we know that it's 60 degrees, right? 60, right? And then when we split it here, though, it becomes 30. This becomes 90. This is 60. Okay, and then that 4 here is the hypotenuse. Okay, so we need to figure out what the short leg is, the apothem, and then the side length, right, for this triangle. So hypotenuse is 4 equals 2 times the short leg, right, which means then the short leg is 2. Right, so here's the 2. Good. And then since long leg is short leg, which is 2 times square root of 3, this long leg here is 2 square root of 3. But the whole thing, double, would be 4 square root of 3. Right. So now we've got the apothem and the side. Okay. So then now let's plug this in. So area of a circle is pi r squared, right? So area of my circle is pi. My radius is 4 meters, and then squared. So that's area of the circle. Okay. Then, okay, instead of doing, so then basically area of a triangle is 1/2 base times height. So 1/2. The base here now we know is 4 square root of 3 meters. And then the height, if this is 2, right, and then here's my circle, right, this part here is 4, so that's a total of 6, right, 2, and then center to the vertex is 4, so 2 plus 4 is 6 meters. There you go. Okay. So then, we're just going to type it all into our calculator. If you want, you can simplify it before you do that. 4 times 6 is 24, 12. 12 square root of 3 meters. Okay, so 16 pi minus 12 square root of 3, and that gives me approximately 29.4809 meters squared. And we'll just say approximately 29.5. Okay, so why don't you try CYP 3A, and then once you're done, come check your answer. Okay, you should have gotten approximately 27.5 squared units. If you got that right, you can get started on your homework. If not, here is your explanation. Okay, so here we want to find the area of the shaded region, and we can find that by doing the area of the whole square minus the area of the circle. Okay. So starting with the square, I just drew a little picture of it, like zoomed in without that circle there. Okay. So we know that from the center to the vertex, that's 8. Okay. We also know about squares is that each of the angles is 90 degrees. And so when we have this segment here, what it ends up doing is it splits that 90 degree in half, making it 45 degrees. Okay. And then here with my apothem for my square, this is a 45, 45, 90 triangle, which we know that the hypotenuse is the leg times square root of 2. Right? So in this case, the 8 is the hypotenuse. So 8 equals leg square root of 2, divide by square root of 2 on both sides, and I rationalize the denominator and simplify. The leg here is 4 square root of 2. Okay? Which means this is 4 square root of 2 as well, which means the whole side of the square is double that. So So double 4 square root of 2 is 8 square root of 2. Okay. Area of a square is just base times height, or length times width, or side squared. So the side is 8 square root of 2, so 8 square root of 2 times 8 square root of 2. Okay. 8 times 8 is 64. Square root of 2, square root of 2 is square root of 4. Square root of 4 is 2, so that's 64 times 2. That gives me my 128. Okay. Okay. And then for the circle, that's pi r squared. However, this 8 is not the radius. This 8 is from the center to this vertex. Note that it's longer than the radius. And so in actuality, this is the radius, right, which we found earlier because it's one of the legs here of the 45, 90 triangle. So this is also 4 square root of 2. So my radius here is 4 square root of 2. Okay. 4 squared is 2 squared, 4 squared is 16, square root of 2 squared is 2, 16 times 2 is 32, so 32 pi, 128 minus 32 pi, and there you go. So that's it for today. Have a great rest of the day. Bye, guys.